First rule we're going to prove for derivatives is the power rule. Power rule works for any function of the form x to the power of n. The proof that we're going to do here proves this to be true for n being any natural number. But with a little extra work, once we've learned some other derivatives, we can actually prove this rule that we're going to develop here to be true when n is any real number. So for all of the proofs that we're going to do, we're going to use the limit definition of the derivative, which we've got written up here in the left-hand corner. The limit as h approaches 0 of f of x plus h minus f of x all over h. This is our limit as h approaches 0 of the difference quotient, or the slope between any 2 points on the line, where h is the distance in the x direction between the 2 points. So if we take x to the n and put it into this limit, we end up with the limit as h approaches 0 of f of x plus h, which is x plus h to the n, minus f of x just being x to the n, all over h. And then immediately we jump to this pretty heinous looking thing, but hopefully we recognize that all of this in the numerator, except the very last minus x to the n, this minus x to the n right here that we have already got, is just the expansion of x plus h to the n power using the binomial theorem. This is just the binomial theorem expansion for x plus h to the n. The next thing that we'll recognize here is that at the beginning of this, we have an x to the n term, and at the end of this, we have a minus x to the n term. Conveniently, those will cancel out. And if you remember from all of our limit definition of the derivative problems that we've previously done, everything in the numerator that didn't have an h in it should have canceled out. And this is no different. So now we're left with a bunch of terms up here in the numerator that all have an h in them. And then we're dividing them all by an h. So term by term, we'll just take n times x to the n minus 1 times h and divide it by h, giving us a limit as h approaches 0 of n times x to the n minus 1. And then we'll look at the second term, n times n minus 1 over 2 factorial times x to the n minus 2 times h squared. Well, that's just going to become an h. So we'll have n times n minus 1 over 2 factorial, or just 2, times x to the n minus 2 times h. And as we go along down the line here, we're going to see that this term here is going to end up with an h squared, and all these other terms that we've left out in the middle here are all going to have an h in them still. And this second to last term in x to times h to the n minus 1 will just become n x times h to the n minus 2 if we divide h to the n minus 1 by h. And this h to the n will become plus h to the n minus 1. I forgot my little dot in here. All of these terms are still going to have an h in them. And as h goes towards 0, the only one that doesn't have an h in it is n x to the n minus 1. And everything else in here becomes a whole bunch of stuff times 0. And the next one is a whole bunch of stuff times 0. And a whole bunch of stuff times 0. And 0. So we can find that the derivative of x to the n is just n times x to the power of n minus 1. And this is what we call the power rule, and it is exceptionally important for all the derivatives you're going to take in calculus.